is the second day of your this course program. So today's topic is, you might be aware as well, that it is that little bit of design part and then the construction part. So we start from here. The layout is something like that. It is little bit on survey and profiling, then foundation works of towers, critical checkpoints, erection, stringing, and then little bit on the design side. So before we start, so may I ask you any idea when ideally the first batch of T&D engineers came into the world? Anyone, any idea? Right. It's about 1880 when the first generation comes, and it was felt that in England as well as US that electricity has to be brought far away from the generating source or point. So the first ideally batch of T&D engineers come into that time. So little bit around 145 years, something like that. And before that, ideally engineering was the first engineering college in the world. Any idea? It is in France, Paris. There is a institute called École de Pont et Chaussées, the School of Roads and Bridges, and that was built around 1750, something like that. Before that, engineering was something not in a stream or faculty wise. But what was the name of the discipline at that time of that engineering? I mean that 1750 or before 1880, something like that. Any what faculty it was? Yes. And what was the reason?
Actually, that time there was no any.
No. The idea was before that also engineering was there, but not in the form of a pure convenient terms of terminology, and engineering used to be for military purpose. So that was the first time engineering was introduced, and that is why it was non-military or civil. And then 1880 onwards, then first batch of T&D engineers ideally, and then the faculty comes into development. So as an introduction, what is common in the nature and us? Anybody from civil engineering background also here? Anyone? No. That's good. Right. So what is common in this nature and among us? In the whole world, whole nature, what is common? Sorry? Is somebody online saying something? Right. It is electricity and magnetism, because when we are ideally not feeling well, we go to a doctor. So almost every part of our body is possible to test through some experiment of some electricity, something like that. So if we go for a MRI scan, it is also fundamentally works on the basic principles of electricity and magnetism. The blood is having the proton, and if you impart one magnetic field, it rotates. So lateral spin and longitudinal spin based on that. So we get some kind of what is the structural configuration in our body, and that is called structural MRI. Similar to that, if we go for a brain, it is functional MRI, and what it is, that how the brain functions. That means how this, something like that. So similar to that, even for the stomach purpose, there is a procedure called electrogastrogram for something for our even this muscle, that is electromyogram, electrocorticogram, that's for the eyes and every part, and of course for the brain also that measures the brain waves, it is called electroencephalogram, EEG. And of course we all are aware of ECG, that basically take the electrical pulse and record it, and we get what is in comparison. So But basic thing is that it compares with respect to a baseline. So when it was in 1800 and I think 65 something like that, when a gentleman from Britain, his name was John Clerk Maxwell, he first introduced a theory, it is called electromagnetic field theory, and that has got a revolution into the natural world. So electricity is there all over the nature. Only thing, when we transmit it through a particular frequency, suppose 50 hertz or 60 hertz, we call it power frequency transmission or power frequency voltage. And that gives, in this setting we will start to learn what is transmission line and how it is done and what are the implications for that particularly. So in general we don't understand, but when a line is in the field, so there is always an electromagnetic field, and that can cause some kind of discomfort into the body or something like that. And those who are in T&D field, actually they might be knowing that there is always some kind of protest or some kind of this grudge from the landowners that could you just shift the line from out of our field, something like that. So these are all certainty are there. Of course, we cannot change that, but when we come little bit under the basic of right of way, how it is calculated and what is the significance of that, that again comes to the fundamental question that what is electricity and how it works, something like that. So we start with the construction part, and mostly people are from very little probably from the design side. So in the end we will switch over, but there is an interface, so we will try to see how it looks. So our layout is something like that. It is starts with survey and design and then erection and stringing, but there is some cyclic relation that deals with operation and maintenance. And of course at certain voltage there are reported failures of towers all over the world. So we will try to catch little bit glimpse on that. And of course in addition to that there are the things which is coming, that is innovation and research, that we will also try to have something. So topic and subtopic, bit of climate change, because all we are aware these days what is happening, and that the climate change is producing some kind of uncertainty throughout the world. So heavy rainfalls, incessant rainfalls, earthquake, something like that. Anybody is aware of that earthquake EQL? So recently might have all are probably aware, there was a latest earthquake in Morocco, and if you just quickly see the YouTube, you will find something. Before 30 minutes or something like that, or after 30 minutes of this earthquake, there have been historically for thousands of years, it has been reported that some peculiar mysterious light comes in, and that is called earthquake light. How it comes? It is suspected, although the root cause is not known, that because of the high energy comes out, probably the static particles of electricity comes into the air, and you will get what we call it earthquake light. Just Google it, YouTube, lot of video will find. And the father of seismology, I think Robert Millet, he first reported that from the Greek civilization it was reported for thousands of years. So these are some kind of, probably we never know whether there is a link or not, but climate change is something, it deals with uncertainty, how we deal with in the natural world. So in this setting, this overhead transmission line, of course when we, as an engineering practice, when we try to do something, of course we rely on the first thing is the standards. So in India, we unless we something or deal with the overseas lines, so we rely on this Indian standards of 5613, that is the code of practice of design, installation and maintenance of lines. IS 3043, that is for earthing, and there are some other IS as well, that is IS 802, that deals with the structural design of these towers and components. So reliability, what is reliability? From the power system point of view, what is reliability? Any idea? So how we calculated reliability? I think those who are in electricity board, I mean PTCL, they might be aware of that. In developed country, ideally they plan for a this reliability indices or index, and that is close to 1. That is number of hours of electricity in service and number of hours of planned outage. So if we take a route, that is given as the reliability index, and that should be close to 1. In developed Western countries, it is something 6 hours per year. It is considered for the planned outage. So 6 hours divided by 365 into 24. That means some 8760 hours, something like this. And if you take the ratio, that comes a figure of 0.999, something like that. So that's the reliability indices. In overhead line, reliability is what we understand. It is the ability to transmit power without any effort, and that's the reliability. Since 1991, this overhead transmission line is designed with respect to the probabilistic concept. What is the probabilistic concept? Because it is different from deterministic approach that was in India for many years. Because I think the first line in India, transmission line, probably near Khopoli in Maharashtra, Tata had built in 1902 or something like that for this Khopoli hydroelectric power plant to transmit the power. In Karnataka, there is one line, there was one line, Shimoga to Varahi, that was again for transmission, that was built pre-independent era, I mean 1940, something like that. I don't think that line is in existence, maybe refurbished, something like that. So reliability is the smooth flow of power, and this IC 860-826, that's the standard based on which our IS 802 is built upon. And that says the transmission system, it comprises of the components. And what are the components? Components are the towers, the structures, maybe wood pole also in some countries, and the conductor and the insulators and something like that. And what is the difference between reliability and deterministic approach? First is it calculates, instead of earlier design, if you see in your board, that earlier design was very robust. I mean, sometimes you see the legs are very heavy compared to, if you see these days 400 kV towers are not so robust. Even for 220 kV tower at those times, the legs were very heavy. The reason was earlier the structural design used to be that you take the total load calculated and you multiply it with the factor of safety. So that is maybe 2 or 2.5. And so increase the load and design for that. Every component of that particular structure or the system should take care of that load. That concept is changed. It is calculated now, the reliability or probabilistic approach. That means what is the probability of the particular wind, say, or ice, whatever it is, in a certain duration of time returns. So say 50 years or 100 years or 150 years, something like that. So it is 1/50, something like that, and you take that, convert into the design, take into account, and you get the reliability concept. And similar to that, in electricity, it is a concept these days is very, very prominent, and that is called resilience. That means as a system, how swift you could get back into the previous condition, that is resilience. So reliability and resilience goes hand in hand, something like that. So evacuation of power, we heavily built on overhead line as well as underground cable. And in India, up to 800 kV, starting from 11 or 33 kV starts in Japan already 100 kV is there. In India also 1200 kV line is there. So it is the various stages are there for the overhead line. It is comprises of planning and design, and then construction, and of course the O&M, operation and maintenance. So when we start with the construction of a line, it typically comprises of many, many kilometers. You start with one position A and you go to the another position B, it takes maybe several kilometers. And for that you need, for the survey purpose, the terrain is of utmost important. Those who have worked in the hill terrain, you may be aware of that what is the difference with the plain terrain. So it is, the terrain is completely different, and based on that the approach is also different. Particularly if the hills are very high, you go towards the mountainous area, there are the complexity is completely changed. So sometimes it is very difficult to take more than one towers even for consecutive and for suspension. So depending on the terrain type, or we call it section length, that is of 3 kilometer to 5 kilometer, normally plain and hilly terrain. Of course, in hilly terrain, almost all the towers itself is a section, something like that, because all the towers are angle towers ideally you put, even though there is angle or not, I mean practically. So code says that in plain terrain you should have a section comprised of 15 span, and in hilly terrain ideally 3 kilometer or 10 span and 15 kilometer, or 15 spans or 5 kilometer. And the hill terrain, the governing thing is that you design it from the uplift condition, because when you have two towers at far distance and in between one tower is at the bottom downhill, so you need to balance the tower. Otherwise what might happen, in a funny winter fine morning, you go there and find one tower is completely missing. That means some kind of something is there. So from the section part, when we come to the individual spans, so there are different, the same span, that is the horizontal distance between any two structure is called a span, but depending on the span there are some different nomenclature for that. It is design span, ruling span, wet span, wind span, something like it. And again that depends on the what is the particular voltage. In India 400 and above kV is normally, it is 400 meter. This has been standardized for a few decades, and that has been in practice for some time and quite relevant to that as well. For 220 kV, 132 kV, 66 kV, so there are different span lengths, and those are little bit less than the 400 kV. So how India is mapped? So when we go here, these days it is very convenient, we intend to go from here to Meerut, so we just open up the GPS and route, Google route, and we go there. But any idea when the first India was mapped actually, that from the survey department, when it was mapped, and how many, what was the duration, I mean how many what the time was taken for mapping the whole country? Anybody is having any idea? If not, just for reference, that it is Great Trigonometrical Survey, GTS, that started in 1802. Ideally it was planned for 5 years, and that time it was British Survey General of India. They started in 1802 or 1805, something like that, and it was planned for 5 years. Although it was taken 55 years, it finished in 1860, something like that. And within this period the Mount Everest is also found, and height was accurately measured. And one gentleman, he was the British Surveyor General of India, his name was his name was Everest, George Everest. In his name this George Everest was there. Right. So in transmission line, that reconnaissance, route alignment survey, detailed survey, check survey, profiling, contouring, benching, and leg extension, these are the standard things. Those who are already familiar with, nothing new for them, but those who are little bit of inquisitive for them. So these are the typical components of that. So what is the reconnaissance? The philosophy is that when we plan to start one line from one position to another position, so we ideally need to have some kind of day studies, and based on those day studies we ideally freeze the what could be the best possible routes. And in there the idea is that the route should be as far as straight as possible. So do you think today's scenario this is still valid? The concept is no, absolutely no, right. because these days it is very difficult to getting the land requisition. So this is, although it is ideal to approach for, the line should be straight as far as possible, but those who are in electricity utility, they are aware that the most difficult part of building of any overhead line is not the construction part, even though it is very difficult to take, but it is the operation and maintenance part. For 20 or 25 years or 30 years, whenever you build the line, after that you operate, that is the thing. Because in case of you need to attend one fault, so the patrolling party or somebody should be very quick to respond to that position precisely within minimum time duration. So that is why these days it is preferable that a line should be not too far away from an existing road. So that's the philosophy. So this is ideally a compromise or trade-off, because anything what we see or what we intend to do, there should be some kind of trade-off in there. So ideally, classically, the route should be as straight as possible, but practically we have to bear in mind that we have to have a very lengthy period of operational maintenance, so it has to be very convenient for approach as well. And prior consultation should be held for the concerned department whenever roads there, because thing is that these infrastructures are expanding very rapidly. So this normally earlier what used to happen, that roadways are there or networks, rail lines are there, but these days a lot of other infrastructure development also happening to keep in recognition of that, for any possible shifting or something like that. Road expansion particularly, that freight corridor like new routes, railway tracks or something is being laid, and so that is scenario is something with respect to these, what are the salient features. And it is desirable, although not enforceable, that when we plan at this point of time, so we understand what is the present day's problem, that getting a right of way or land requisition is the most headache for anybody concerned with that. So what could be the down the line, say after 20 or 30 years. So it is not a unwise idea to have some kind of vision into there. So in case of any possible alteration or change, so what should be the scenario. So these are the reasons behind the reconnaissance survey is very essential. So of course the nature of soil strata, availability of other things, there something like that. And of course there are statutory regulations for roadways, highways, and these railway tracks and everything. And subsequent to that, the very first thing for a new build line, so when you have one new line in mind in planning stage, you intend to do that, that takes into account the route alignment survey. So these days we very easily we switch on to Google Earth, but that wasn't the thing I think 30 years back, because people used to have the topographical survey report first and topographical map, we plot on that and compare and something like that. The scenario, the thing is that these days topographical map are getting very recent developments, because habitation is coming, industries are coming, and every infrastructural development are coming. So those point of view, Google Earth is fine, absolutely, but again Google Earth also sometimes, depending on the location, that doesn't give the precise today's position actually. Sometimes Google Earth, what you see on there, that imagery itself may be 1 year or maybe 2 years back, unless, and that again depending on the location it is varying, unless you go for a very this minute area, and that is called this private imagery. So it is possible to get that private satellite imagery as well. There are many private players in India also, that space research is a little bit going for privatized something. So in US also there are many private satellite imagery. Google used to have their own satellite satellite system. I don't know whether they still own, but they did have. and Google imagery or Google Earth, they tend to brought in from there. Now, when you go for route alignment survey, if the terrain is again, if not if not plain, if it is a hilly terrain, then also sometimes you need to have, desire us to have some kind of first-hand knowledge about one very important phenomena for these days, that is landslide. That is a globally phenomena, and almost it is everywhere in every parts of the world, landslides is happening. So, if you intend to plan one new line in any area, particularly for you guys where you work for the hill areas, so it is, you may be aware that in Google Earth imagery, there is also some historical image that you can retrieve for few years, up to 20 years. So, if you see, possibly you will get some ideas whether there was previously incidents of landslides, that you would give some benefits or comforts to plan whether to. At present, there is no prevention mechanism for landslide, you may be aware. So, only thing what we could avoid the areas which is likely to prone. But there are some other methods as well. I mean, that's a separate thing. It itself is a huge topic. So, anyway, so route alignment, these are the things. But in case of landslide, one thing is very common that has been mentioned in the NASA this landslide related journal papers also, that is landslide is most likely the cause is the rain or precipitation. So, obviously in the monsoon season we get the landslides. So, the steepness of an area, the slope and multiplied by the rainfall intensity, that gives the susceptibility of landslide. So, coupled with that, there are many other factors, those are similar to that, what is the geomorphology of that area, what are the lithology, study of rocks in that area, something like that. Because in overhead line, whether you go for a substation on new lines or something like that, your foundation depth is limited to 3 to 3.5 meters, something like that, and that is called the soil profile. But geological profile goes much below that, and we are aware that water table is going down. So, many unforeseen challenges are likely in the present scenario, particularly in the event of the climate change is happening, and so much research work is also happening for that. So, once we finish up a route alignment survey, we start with detailed survey, and the detailed survey, we are aware that these days, the earlier it was used to be with theodolites and all kind of leveling instrument, dumpy level thing. These days it is all DGPS, I mean digital geopositioning system, something like that. So, I think we all are aware of GPS, aren't we? What is GPS? But what is the technology of this? What is the technology behind GPS? Is it what GPS is actually? Anybody, any idea? The technology is something GNSS, Geo Navigational Satellite System. That means 4 or 5 countries in the world, they have their own satellite communication system. The first was GPS, that is Global Positioning System by US. They have 6 orbital planes and they have 32 satellites. Maybe few are not operational these days, from 1990s or little bit early from that, and they tend to give the position from each satellite onto our handheld receiver. India also we have NAVIC Indian Regional Communication System that captures 1500 kilometer, including I mean from the center of India, something like that. So, if you go up to those areas, something Cambodia, Laos, you will get the NAVIC signal as well. China has their own satellite system that is called Beidou. European satellite system ESA, European Space Agency, they have their own satellite system that is called Galileo, and Russia is also having their own satellite system that is Glasnost. So, when you open up any GPS position, you will likely get many satellites. So, and you get that, and it may not be necessarily for the one particular GPS, something like that. You may be having some from Beidou, some from Indian Regional Satellite System, something like that. and you will get, when you get all this, you will see many satellites. But any idea, if anybody is work with the smart grid, so what are the minimum number of satellites we need to get one signal? 4 years. What is the reason behind?
Three dimensions are X, Y, Z.
And 3 is, yes, absolutely, X, Y, Z. And why you need 4 then?